That is VF means that is where what is our V, that is Rn, and what is field, that is set of real number. So we have to show that Rn over R is a vector space. So first what we do when we uh, start proving that this non-empty set is a vector space. So beginning, but we define some operation, and that operation is, we first define vector addition and second define scalar multiplication. So let x, y, this belongs to Rn and over the field R. So these are the elements x and y. This belongs to Rn. So can someone tell me how we can write this x? ये किस टाइप का एलिमेंट होगा? Yes, anyone? Yes, anyone?
N tuple x1, x2, x3 up to so on xn.
Very good. Okay, now you can mute. So x1, x2, x3. Please mute your audio. So this belongs to Rn. Similarly, this y, this also belongs to Rn. So y is look like this: y1, y2, y3, and yn. So this is n tuple element. This belongs to y, also belongs to Rn. So y look like y1, y2, y3, so yn. So now how we can define? So we define vector addition xy, and that is equal to, this goes to x plus y. Now how we can define this? So this is x x1 plus x1 comma x2 comma x3 and xn plus y1 y2 y3 yn. So the sum is, we add first element with the first element of second vector. So we get x1 plus y1. This is usual addition, right? How we can add? So x2 plus y2, x3 plus y3, and similarly xn plus yn. This is how we can define addition. Similarly, we define, because x and y both belongs to vector, so this addition is called vector addition. X and y both are vectors, so we call this a vector addition. Now we take one element from field. Let we take alpha, and field is set of real number. We take field to be R. Alpha in R and any vector x in R. Then we define scalar multiplication alpha x, that goes to alpha dot x. Now how we can define this? Our alpha is, because it belongs to R. अगर R में है तो it is not like alpha 1, alpha 2, alpha 3, alpha n, because our field is set of real number. So real number में हमारे पास सिर्फ alpha होगा. Alpha dot, but x, this x belongs to Rn. तो Rn में है तो x किस टाइप का होगा? It is n tuple element. x1, x2, x3, and this xn. And we define this. When we define something, so we use this notation, because we write like this. This is defined. We use this notation when we define something. So this is alpha x1, alpha x2, alpha x3, and so on, alpha xn. So these are the operations we first define. How we can define addition, how we can define scalar multiplication. So now we come to the property number 1. Can someone tell me what is property 1 under addition?
Property under review.
Commutativity under addition. Very good. So we take given any x, y in Rn. After giving response, you please mute your audio. When we call someone, then only you can unmute your audio. Otherwise, after answering, immediately you mute yourself. So A1, that is for every x, y, x comma y belongs to Rn, such that what we have to show? We have to show that x plus y is equal to y plus x. Our goal is we have to prove that x plus y is equal to y plus x. So we start with x plus y. So what is x? x1, x2, x3, so on, xn. What is y? y1, y2, y3, yn. Now, how we can add this? How we can add this?
Sir, x1 plus y1.
Yes, x1 plus y1.
x2 plus y2.
Yeah, because it is defined. It is already defined, so we use the
X3 plus Y3.
very good x3 plus y3,
And so on x
So on.
n plus yn.
okay, one by one.
xn plus yn.
Okay. So can someone tell me, can we write like this? Can I write this as y1 plus x1?
Yes, sir.
How?
Yes, sir.
Sir.
Yes, sir.
How can we write this?
Sir,
Y plus X.
y plus x. Sir, x plus y जो है वो y plus x के इक्वल है.
वो तो हमें प्रूफ करना है.
Yes, sir. Sir, x comma y belongs to real number and commutativity under real exists.
Very good. Is this point clear to everyone? Here,
Yes, sir.
here y1, y2 जो हमारे y1, y2 हैं, they all are real number. y1, y2, yn, they all are real number. Here x1, x2, xn, x1, x2, x3, xn, they all are real number, right? They all. So in last class, कल जो हमने पढ़ा था, we discuss about the properties of real numbers. And what is the property of real number? They satisfy commutativity, associativity, they are closed under addition. So x1 plus y1 is equal to y1 plus x1. देखो x1 is a real number, y1 is a real number, and we know that x1 and y1 both are real number. And yesterday in last class, what we do, we prove that sum of two real number, they satisfy the commutativity property under addition. So because of commutativity of under addition of real number, we can only write this x1 plus y1 equal to y1 plus x1. Now can I write x2 plus y2 as y2 plus x2? Can I write this as y2 plus
Please
x2?
mute yourself, bhai.
Yes, sir.
Yes, sir.
Yes,
Sir, we can.
How? Because x2 and y2 both are real number.
Yes,
And real number satisfy the property of commutativity under addition. So we can write x2 plus y2 as y2 plus x2. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
And similarly yn plus xn. And because of vector addition, what we have defined, I can write this as y1 y2 yn plus
X1, X2, so on Xn.
x1 x2 so on
Xn.
Very good. So this is nothing but this is y and this is x.
X.
So for every xy in Rn, so this implies given any xy in Rn such that x plus y is equal to y plus
Y
x.
plus X.
So it satisfies the commutativity under addition. Is it clear to everyone?
Yes.
Take 10 seconds and
Yes.
quickly revise this one. But the important thing is how we can use the property of real number, right? ये इसको क्रैम नहीं करना है कि x1 plus y1 है तो उसको हम y1 plus x1 लिखते हैं. रियल नंबर ने हमें ये प्रॉपर्टी दी. We have already proved कि real number under addition it satisfies the commutativity property. Okay. So what is the next property A2?
Associativity under addition.
Okay. So can you tell me how we can write this? For every x, y, z in Rn, but we have to, this is our goal, x plus y plus z is equal to x plus
Y plus Z.
Y plus Z.
right? So this we have to prove. Now we start with x plus y plus z. Now all of you know how because this x belongs to Rn, so this look like n tuple. Y is y1 y2 yn, z is z1 z2 up to so on zn, right?
Yes,
So we
sir.
first write x1 plus x2, sorry, x1 comma x2 xn plus y1 comma y2 yn plus z1 z2 zn. Now in bracket, first bracket, how we can add these two numbers?
Sir,
Yeah,
x1 plus
we can
y1
write this as
y1,
x1 plus y1,
x2 plus y2,
x2 plus y2,
so on xn plus yn.
so on xn plus yn. And plus now we add with new vector, that is z1 z2 zn, right? Okay. So can someone tell me what is the next step?
x1 plus y1
x1 plus y1
plus z1,
plus z1.
x2
क्या मैं
plus
इसको ऐसे लिखूं? Is it the right way to write?
No, sir. Sir, x1 plus y1 को ब्रैकेट में लिखेंगे.
Okay, x1 plus y1, because this is one vector.
Yes.
We add this vector with z1. So x1 plus y1 plus z1. Then x2 plus y2 plus
Z2.
z2. Then xn
So,
plus
Yn.
yn plus
Zn.
zn. Okay. Yes. So What is the next step?
Sir, x1
Okay, x1
bracket plus
plus
bracket y1
bracket
plus
y1 plus
z1.
ऐसा क्यों लिखा है इसको?
सर क्योंकि x1 y1 नहीं सर x और yz जो है वो
सर
रियल नंबर्स को बिलोंग करते हैं।
xy तो Rn में है ना,
यस
xyz Rn में है, और Rn में हमें एसोसिएटिविटी प्रूव करनी है, तो हम इसको ऐसे इस तरीके से कैसे ब्रैकेट इंटरचेंज कर सकते हैं?
Associativity holds in
रियल
real
नंबर
यस, एसोसिएटिविटी, बिकॉज ये x1 क्या है? x1 इज अ रियल नंबर सॉरी, x1 y1 z1 they are real number, they belongs to real number, right? और real number में they satisfy the associativity, x1 plus y1 plus z1, that is equal to, that we can write this as x1 plus y1 plus z1. So because of the associativity of real number, we can write only this. Is it clear?
यस सर
यस सर
yes sir,
Similarly, we can write this as x2 plus y2 plus z2 and xn plus yn plus zn. And now we make the grouping, because this is one vector, this is second vector, this is one vector, this is second vector, this is, so how we define the addition? We define addition like this: first vector plus second vector, we can separate them. So how we can separate this? We can separate like this: x1 x2 xn plus y1 plus z1 and so on. You know how yn plus zn. And now we also write this as, we can also separate this. How we can separate this? Yes, anyone?
सर
y1 plus y1 comma y2
y1 comma
y2
y2
so on up to yn
yn plus
plus
But
z1
we put bracket here, right?
yes sir
Plus
z1
z1
comma z2
z2 comma zn.
yes sir
And this is nothing, this is x plus y plus
y z.
this satisfy the associativity. Okay, so come to third property. Yes, anyone? What is the third property?
existence of
Existence of
identity
additive identity.
Existence,
under addition
yes, existence of additive identity. Identity come first, then we talk about inverse. पहले आइडेंटिटी आती है, देन उसके बाद हम इनवर्स तभी हम फाइंड कर पाते हैं. The existence of additive identity. How we can write? How we can write this? Anyone?
There exists 0.
There exists
0
zero.
belongs to Rn.
zero vector
Yes, zero vector. Very good. So there exists zero vector. 0v belongs to Rn, because Rn is a vector. अब ये जीरो फील्ड रियल भी हमारा जो फील्ड है दैट इज रियल नंबर. अगर आप सेम जीरो लोगे तो वेक्टर और फील्ड का जो रियल जीरो है वो आप उसको सेपरेट नहीं कर पाओगे कि कौन सा वेक्टर का है कौन सा फील्ड का है. ठीक है. सो वी टेक जीरो वी इन आर एन. वेरी गुड. यस. Such that
there exists X
there exists
For all.
for all.
For all.
for all
X belongs to Rn
x in Rn
such that x plus 0 v is equal to x.
x plus 0 v equal to x. Right. So this is the additive identity. But how we can prove this? We take x plus 0 v. We start with x plus 0 v. What is our x? x1, x2. Yes. Someone tell me what is how we can write 0 v.
0, 0,
0,
0,
0,
0 tuple.
Yes, it is 0. And we know that how we can add. We have already defined. So
x1 plus 0, x2 plus 0 up to so on xn plus 0.
and this is
x1
x1. How can we write this?
because 0 is the additive identity of real numbers.
Because of the identity of x1, x2, x3 and so on xn. And this is x. So x plus 0 v equal to x. There is no need to prove 0 v plus x because in first property we have shown that they are commutative. It satisfies the commutativity under addition. So x plus 0 v is also equal to 0 v plus x. Is this point clear to everyone?
Yes, sir.
Or quickly tell me what is A4?
Instance of
Additive inverse.
So how important the properties of real number. बिना real number की property पढ़े you cannot. फिर वो cramming थी. अगर आप इसको x1 plus 0 को x1 लिख रहे हैं तो you just cram the part. But when you use the property कि x1 plus 0, x1 belongs to real number, 0 belongs to real number, and in last class what we do कि under 0 is the additive identity of real number. Any number we add with 0 then we get the same number. So x1 plus 0 that is equal to x1. It is only due to real number. So existence of additive inverse. How we can write this?
For all x belongs to Rn
For all Rn
such that there exists a unique y belongs to Rn such that x plus y is equal to 0v.
x plus y equal to 0v. This is important. X plus y equal to 0, then 0 is a scalar. But sum of two vector is again a vector. So it is not 0, it is 0v. Okay. So we start with x plus y. This is very important part, right? So try to focus on how we can prove this. x1 plus y1. X plus y. What is our x? This is x1, x2,
So upon xn.
xn plus y. Y is y1,
y2,
y2,
so on yn.
yn. How we can add? We have already defined this. So x1 plus y1, we add first element with first, second with second,
x2 plus y2, so on xn plus yn.
xn plus yn. Right? Okay. but it is given. Sorry, we start with we, we have to find y, right? So we take this is equal to 0b, we have to find y. So this is x1, x2, xn plus y1, y2, yn. This is equal to 0 means 0 0 and tuple 0. So addition is defined like this: x1 plus y1, x2 plus y2, xn plus yn, that is equal to 0 0 0 0. Now what is my next step?
Sir, x1 plus y1 is equal to 0, comma x2 plus y2 is equal to 0, comma up to so on xn plus yn is equal to 0.
How can we write?
Because two vectors are equal only when their corresponding elements are equal.
Very good. So uh, we have two vectors. Let x is equal to y. Two vectors are equal if and only if. But when we say two vectors are equal, x is like x1 x2 xn, that is equal to y1 y2 yn. Two vectors are equal if x1 is equal to x2 y1, x2 is equal to y2, and similarly so on, xn is equal to yn. So if they are equal, so in general how we can say two vectors are equal, x is equal to y, if and only if. This is a symbol for if and only if. For every I lies between 1 to n. For every I lies between 1 to n, xi such that xi equal to yi. और x1 y1 के इक्वल हो, x2 y2 के इक्वल हो, x3 y3 के इक्वल हो, then we say x equal to y. और x equal to y है, इसका मतलब corresponding elements equal है. If and only if means both way it is true. अगर x y के इक्वल है, वेक्टर इक्वल है, तो उनके corresponding element इक्वल होंगे. और in other way what we say, if order elements or if their order pairs are equal, corresponding elements are equal, then we say the vectors are equal. So when this vector and this vector, they are equal, how we can compare? It means first element of this vector is equal to first element of second vector. So x1 plus y1 is equal to 0, x2 plus y2 is equal to 0, and similarly xn plus yn equal to 0. Is it clear to everyone?
Yes, sir.
Okay, so tell me what is the next step? Yes, anyone?
y1 is equal to minus of x1.
y1 is equal to minus of x1. कैसे लिखेंगे इसको?
सर बिकॉज अगर कोई भी हमारे पास दो रियल नंबर्स है और उनका सम 0 के इक्वल है, तो इसका मतलब हुआ कि उसमें जो ऐड किया है एलिमेंट वो उसका इनवर्स है.
कल हमने पढ़ा था a plus b equal to 0 रियल नंबर की प्रॉपर्टी है. a plus b equal to 0, then we find that b equal to minus a. a plus b equal to 0, so b equal to minus a. ये हमने कल प्रूफ किया था. So because x1 is a real number, y1 is a real number, and 0 is a real number. So this satisfies the property of real number. Only then we can write y1 is equal to minus x1. Because of the property of real number, then only we can write this, that y1 equal to minus x1. Similarly, we can write y2 equal to minus x2, and so on, yn equal to minus xn. So if y is equal to, if our y is equal to y1, y2, yn, then this y look like minus x1, minus x2, and minus xn. We can take minus common because second property, scalar multiplication. So we can take minus common, then it become minus x1, minus x1, minus x2, and xn. And x1, x2, xn is nothing but it is x, so minus x. So y equal to minus x. So this is the additive inverse. So therefore, y is equal to minus x is the additive inverse of x in Rn. अब y क्या है? y1, y2, yn. तो माइनस x क्या होगा? माइनस x1, माइनस x2, माइनस xn. और x1 में माइनस x1 ऐड करोगे, इट बिकम जीरो वेक्टर, जीरो. It gives us 0. 0, 0, 0, it becomes 0v. Take 10 seconds and revise this part. If you have any doubt, you can ask.
Students, you can ask.
Sir,